Okay, so we have here a sample problem on how to calculate the heat needed to vaporize 35 grams of water at 100 degrees Celsius. So this is one of the problems I posted in your classwork. So how do we solve this problem? So if you notice that the given is 100 degrees Celsius, so that means that it's already starting to vaporize because boiling point of water is 100 degrees Celsius. So really, we only need one equation here because all we gotta do is to figure out how much heat will be needed to vaporize 35 grams of water. If the problem is saying not 100 degrees Celsius, or let's say for example, if it starts from 25 degrees Celsius, you want to vaporize it, then the solution would be different. So we will explain that later. So now we have here, we will use our equation Q equals mHV. Mass for M for water, H for heat of vaporization, which is actually a constant for water. So heat of vaporization is actually equal to 540 calories per gram. So that's already given as a constant. So all you gotta do is plug that in. So here we have 35 grams times 540 calories per gram. You can cancel the grams here. So we have grams cancel here and there. That would be equal to 18,900 calories. Now, the problem is not really specific whether or not to calculate the heat in calories or in joules. So your answer would be either way. So if your answer is calories, that's fine. If you want it in joules, you just simply multiply it by 4.184 joules per 1 cal. Cancel out calories. You just simply multiply that number to this number for you to be able to get your answer in joules. Now, let's try another problem so then you understand why, Ms. D, that you are not going to use Q equals MC delta T in this case. So for example, let's twist the problem a little bit. So supposing the problem is asking us, calculate the heat needed to vaporize 35 grams of water at 25 degrees Celsius. So over here, it is 25 degrees Celsius, not anymore 100. So here, we really have to raise up the temperature first from 25 to 100 because 100 is the boiling point. So in other words, we have to use our first would be Q equals MC delta T. All right, where mass is still 35 times specific heat of water. If we use a calorie, then we would just use 1 cal per gram degrees Celsius, and then times the change in temperature. Of course, we want to bring it up to 100, so then it starts to vaporize, right? That means it will change to gas, from being liquid to gas. So our change in temperature, therefore, would be 100 is our final, minus 25 is our initial. That would give us a 75. Okay, that would be our answer for that. So then you simply multiply 75 times 1 times 35. That would give us a 2,625 calories. So here we were able to calculate just the heat to bring up our water from 25 degrees Celsius to 100. And then the second step would be, this is our first step. The second step, now that we were able to bring our temperature to 100, then we can calculate vaporizing it using our Q equals mHV. So, which we already have in our previous previous problem. So remember this one right here? right? So that would be the equivalent of our second process, second step. So 35, which we will just put that in over here. We have 35 times 540, 540, that would give us 18,900 calories. So then we just simply add up our calories. So total, therefore, the total amount of heat needed here would be the combination of the two. That would be equal to 2,625 plus 18,900. Okay, so that would be equivalent to 21,525. So total would be 21,525 calories. Now you see the difference. So here again, the difference in the previous one is this one is starting from 25. So we have to bring it up to 100. So then by the time it's 100, it's now ready to vaporize. Whereas in our previous problem, here the temperature is already 100. So we really don't need the Q MC delta T here, but only Q equals MHV. I hope that clears some confusion.